Hi, my name is Dillon Tracy. At this point, if you guys have seen either the keynote by Stephen Wolfram this morning or the other keynote by Tom Wickham-Jones this morning, you've had some exposure to the cloud, and you may even have played with it a little bit yourself already using a free account or something else. The purpose of this talk is to give you a little bit more in-depth exposure to what the data science platform is and is going to be, and how the workflow is going to work. So I'll talk very briefly about how this data science platform fits in with the other cloud offerings that we have and will have, why you might want to do data science in the cloud in the first place, why that's a good thing, and then I'll go through a few concrete examples to show you what the workflow looks like. Okay, so earlier this summer we launched the programming cloud. Stephen Wolfram mentioned this morning. The emphasis in that cloud platform is on deployments, on prototyping, team collaboration, managing your deployments, counting the money as it rolls in, et cetera. And then late in the summer, early in the fall, we launched Mathematica Online. The idea behind this one is to extend the Mathematica desktop experience into the cloud. So the data science platform is in this stable. It's in this portfolio of stuff, and the emphasis here is going to be on this sort of bread and butter data science workflow: import something, analyze it, publish a result. And I'll show you concretely how that works. So on the upstream end, you're going to have data that could be structured or unstructured. It could be sitting in a database. It could be sitting in a file. It could be being updated in real time. It could be static. You're going to bring it into the Wolfram system, where you'll be able to leverage some semantic interpretations on the data, and you'll do your Wolfram language customizations, work up your visualizations, and so on. And then on the downstream end, you go through a CDF templating step where you can produce a customized document, often with interactive elements that you can get in front of a decision maker. All right, so why would you want to do data science in the cloud? I think the answer has something to do with accessibility and reach. So we can think by analogy a little bit. If you have not yet yourself played with the idea of an API function, you may have seen Stephen Wolfram do it this morning. So functions are now fluid things. You can not only write and execute them in your desktop environment, but you can cloud deploy them. And once you do that, they execute in the cloud. Once that happens, so for example, I deployed an API function yesterday that returns a map of a country. Here, this one is returning a map of Italy. This request is coming from my browser. The computation is being done in the cloud, and the response is being served back to my browser. My browser doesn't know what technology stack is running up in the cloud. It doesn't care. It just makes an HTTP request and gets a result. So that has the effect of sort of democratizing computation, right? So 20 years ago, or even a few months ago, if I gave you a piece of Wolfram language code and I told you to execute it for me, it would have been an acceptable excuse to say, I don't have Mathematica. But that excuse doesn't exist anymore, because I can publish my stuff as an API function, and you have a browser, right? So something similar is happening to computable documents. So these desktop notebooks that we know and love with all their wonderful interactive elements, now that they are usable in an unaugmented zero configuration web browser, there's an analogous phenomenon happening where the access to results is being democratized. And this solves a very serious problem in data science workflows. At gatherings like this one, I've had many conversations with people like you who have done marvelous analyses, worked up these notebooks, doing all kinds of wonderful things, and you say, well, what happened? How did this play out in your organization? What kind of change took place? And then the person you're talking to says, well, my boss doesn't have Mathematica. And you say, well, couldn't he install the CDF browser plugin? And they say, well, IT wouldn't let us do that. And then you say, oh, and the conversation goes. So that's happened enough times that's happened enough times that I'm excited about solving this problem, and I think that's sort of one of the killer apps of the killer features of doing data science in the cloud. So let's play with some real data. So here's some real data. This is a spreadsheet of bigger. This is a spreadsheet of house utilities that I keep on my house. It goes back. It's just monthly data that goes back a few years, and it's just a simple rectangle of data with half a dozen columns that's kept in a cloud spreadsheet, and here's the URL for it. So I'm going to import this data into my desktop session, I not only imported it, but I semantically imported it. So this is a new function in version 10. You may have gotten a glimpse of it this morning. So this is not only going to take care of the mechanics of tearing apart the file and getting it into the Wolfram system for me, but it's also going to attempt to recognize entities in the file. So this just took in a raw CSV. It was just text, but it still managed to recognize the dates as dates. That's what these funny yellow-orange boxes are on the left. And then fields that contained dollar amounts are marked as having units. Okay, so this is taking a lot of the sort of workaday sting out of doing data science. These are the kinds of things you used to have to do by hand, but you don't have to anymore. All right. This thing that's being returned is a data set with a capital D, and there are all kinds of funny queries that you can do on it. That's sort of its own conversation. That's its own topic. Just as a very, very basic example, I'm going to show you this command will extract 2 columns and then give them to a visualization function. And then this will show you my electricity usage in kilowatt hours going back for a few years. Okay, that's all on the desktop. I'm going to switch to the cloud now. Okay, so this is what will that magnify well? So this is what the front page of the data science platform looks like. These big red buttons across the top are quick starts for very common workflows, getting data in from a file that you have in the cloud, getting data in from a file that you have on your desktop, getting data in from a URL. We have data in a URL, so let's go through that. Let's duplicate this desktop workflow in the cloud. So I'm clicking import data from URL. I'm going to paste this URL here. And when I click continue, the platform is going to make a notebook for me that is seeded with some code to help me start my analysis. Okay, so this is a normal Mathematica notebook. It's a normal Mathematica notebook in the cloud, and all the things that you're used to doing in a notebook can be done. These buttons this is a template notebook, which is a special kind of, it's an augmented kind of notebook. These buttons across the top allow me to place and control the behavior of template variables. These template variables can be filled with whatever I want to fill them with when I generate a customized document from this template. And this is useful for customized reporting at the downstream end. But at any rate, the same semantic import that you just saw happen on the desktop can now happen in the cloud. And the kind of visualizations that we do on the desktop can also happen in the cloud. Okay, so what you're seeing here is the corresponding cloud operation to what we just did on the desktop, and here's the corresponding visualization to what we just did on the desktop. So this is not yet a very compelling report, but let's pretend that it is, and let's deploy it. So I'm going to press this big red deploy button and click automated report, and then this GUI pops up, and it's got all kinds of levers and knobs that I can twiddle, like the output format, and people I want to receive copies of this report, and what schedule I want to run it on. Let's say I want to run this. I get my utilities bill once a month, so let's run this late in the month. And I click create. Okay. Now this template, along with some other things, is bundled up into this entity on the server, and it now appears in my reports listing in the sidebar here. It's this one here because I didn't give it a name. If I want it to run now, I don't have to wait for the end of the month. I'm going to click this little gear menu and click Run Report Now. When I do that, the server is somewhere up in the cloud. A server is grinding into action. A kernel is being launched. This template is being applied. A log file is being generated. The resulting document is produced. It's archived, and it's sent to all the people who are listed as recipients for the document. And that, yeah, here it is. So if I click this link in my notification email, it should open the resulting generated document in the cloud. Okay, good. So there's my report. As I say, that's not so compelling yet, but imagine if I worked on that problem for a couple of hours, okay? So I spent some more time doing more sophisticated visualizations. I could be working on the desktop and uploading the template. I could be working right in the cloud interface. And let's say after a couple hours, I came up with this. Okay, so this is working on the same data, and you can see my semantic import. Things have gotten a little bit more sophisticated. I'm doing some row deduplication for cases where the utilities company made a mistake. You can glimpse some visualization functions in here, some dateless plots. Here's some histograms. some paired histograms. Here's some forecasting using more sophisticated stuff like time series model fit and time series forecast. And when I'm happy, I can evaluate this just as I would a normal notebook, but it gets compelling to other people when I deploy it as an automated report. So again, I can go through this GUI, press create, get a report in my sidebar, and ask it to run now if I want it to. While we're waiting for that to chug, I think I can show you. I think I can show you the results of a previous run. Let's see. Yeah, okay. So here, these orange peaks are my gas usage in the winter, and these blue peaks are my electricity usage in the summer. And here we've got some distributions of my kilowatt hour and therms usage, and here they are broken out by season. And here's some forecasting. Here's my combined gas and electricity usage. Here it is projected out 12 months using a seasonal adjusted SARIMA model. And here's what I'm on the hook for this fall and winter. So there are all kinds of directions that you could take this in. You may want to compare how the prediction from last month matched up to the actuality for this month and so on. But we've already been able to cover the workflow from one end to the other. So this is a document that could be that can be consumed, that can be put in front of other people. So we went from one end, the raw data, to this pretty quickly. And the hope is that these deployments of these automated reports will be pretty lightweight. And you can do lots of them very quickly, and the turnover for them will be short. Okay, I'm going to flip back to the desktop now. All right, I want to show you a little bit more about what you can do with semantically imported data. So this is a cute data set. This is a tree inventory done by the city of Champaign. So here are the columns that you get. You get a tree species and a common name, and then you get some stats about the size and shape of the tree, and you get a location. You get a latitude-longitude pair. All right, so I'm going to semantically import this data set. This time I'm going to give the interpreter a hint that the first column contains a plant. Okay. Try that again. That the first column contains a plant, and the interpreter will attempt to assign a plant species to that column. Once that semantic import finishes, I'll give you a glimpse of what the raw results of the semantic import look like. Once again, we're on the desktop here. There's no cloud involved yet. Okay, so if you look in the left-hand column here, you see that some of these, in cases where there actually was a tree and not a vacant site or something, you get an entity back and this entity has curated metadata attached to it. This is an idea brought in from Wolfram Alpha, and this metadata is available to you in your analysis and can facilitate the kind of this so-called knowledge-based analytics. Also notice that the position has been wrapped, the latitude-longitude pair has been recognized as a latitude-longitude pair and has been wrapped in geoposition. This will make mapping applications easier, as we'll see. Okay, so to give you an idea of the kind of, where did my mouse go? To give you the idea of the kinds of things that knowledge, oh, Alpha's complaining, that knowledge-based analytics gives you access to. If I ask for the number of properties associated with the red maple, I get nothing. I get about 150. And so, for example, I can ask for the foliage color of the red maple, and this may or may not come back. As green. Okay, so let's do something similar in the cloud. So here's a template that I worked up in the cloud to look at the same trees data set. So here you can see me doing the semantic import of the trees data set. I'm going to do a little bit of munging on it. And then I'm going to do some data science-y stuff where I look at like the top 5 most common trees. And then I'm going to, you see this geographics here. This is a super fun feature new in Mathematica 10 that's going to do some mapping of the tree species. I'm going to zero in on the ash trees. I'm going to isolate one of the species and look at them. When I'm happy with this, I'll do the same thing that I showed you before: deploy, automated report, create, and I'll get this trees template report. Ask it to run now. While we're waiting for that, I'll show you the results of a previous run. Okay. So here are the 5 most common trees in the data set. These thumbnails of the tree species came for free with the metadata attached to the entities. I didn't have to go look that up. I didn't have to do any work at all. It was just a property attached to the entities. So that came for free. Here's a pushpin map of the sampling of the tree locations, color-coded by species. Where are we? We are, I guess, at that intersection. A lot of distinct tree species, so this is a little bit busy. If I isolate the ash trees, things get a little bit more manageable. So all of the ash trees in Illinois and many parts of the United States are being eaten by these. These are emerald ash borers. They're thought to have come over from East Asia and packing material. This data set did not contain data on sick trees, but I found myself wishing that it did, because that would have been neat. So I made up some data. I simulated some. So here's some simulated sick trees based on a 2-dimensional distribution. And then I colored the sick trees red. Okay, so you can see this outbreak, this ash borer infestation west of I-57 in this map down here. So you could, if you worked for the city or something, it would be nice to have this in your email every Monday, right? In fact, for the data science course that I taught yesterday morning, I worked up an example where we used the machine learning functions, the classify functions, to identify candidate sick trees in the rest of the city based on the characteristics of the ones that were actually sick. Okay, so if provided that approach actually makes sense, if you can predict vulnerability to ash borers based on the kinds of things that arborists measure in these kinds of data sets, then that would be a real labor saver, because the city only has so many trucks and so many arborists to send around. So it could be an interesting application. Okay. So everything that you've seen so far in the cloud has been kind of GUI-centric, but we think very hard about language design, and it's generally the case that everything you can do with the web GUI has a corresponding language equivalent. So these automated reports, these bundles of stuff that execute up in the clouds, are known in the language as document generators, and I'll show you briefly how these work from the language level. So here I am back in the desktop. Let me show you a very simple template. Okay, here's a super simple document template that has one slot in it for an author. I'm going to deploy an automated report using that template from here, from the desktop. Okay, so that's a one-liner. That's this. It uses this cloud deploy idiom that we use to cloud deploy everything. I'm going to specify a document generator with that template. And minimally, that's all you need. You don't even necessarily need a schedule. So I'm going to deploy that now. Okay, so that thing's being bundled up and sent to the cloud right now. Once that's up there, I might want to trigger it to run without waiting for its schedule. In this case, it doesn't have one, so I have to trigger it if I expect it to run at all. And there are 2 ways that I can do that. I can do that in a blocking way, where I wait for the result, or I could do that in a non-blocking way, where I let it go do its thing as if it had been triggered by its natural calendar trigger, and then wait for an email notification or go check it later. So here I will evaluate it in a blocking way. So right now, evaluation of that thing took place in the cloud. I got back a cloud object, and if I click on this, this should be the document that was generated by that generator. There it is. Okay. So to go back to that utilities example, if you wanted to deploy that from the desktop without going through that web GUI, if you want, that's just this. It's a one-liner. Here, this one has a schedule monthly. So as I say, the intention here, the hope is that these deployments will be very lightweight. And like here at Wolfram, we have an enterprise data warehouse, and there's a team that manages it and works with it. and requesting a report to be set up in it it's not a heavyweight process, but there's some process there. And the hope is that this will be much more maneuverable, right? That I could deploy 10 of these in a morning if I wanted to, with slight variations for different people. And here I'll tell this one to run asynchronously, just for the heck of it. I'll leave you with I'll give you a glimpse of a more complicated example. So here's a template for a stock report. Let's give you a bit more of a sense of what you can do. All right, so this stock report is fed with a bunch of tickers. You give it a list of tickers that you want a stock report on and then it uses the financial data packlet to look at some properties on those instruments, and then it gives you back little interactive widgets that let you explore those properties over the time series of those properties over the past m days. Okay, this makes use of a template feature called the repeating block that allows a template to handle a variable number of elements. So I could give this template 1 instrument or 5 instruments or 50. Okay. Now, let's say I'm working at a financial company and somebody says to me, I want a daily report on the performance over the past 30 days of the 5 stocks in the trucking industry that had the highest trading volumes on the previous day. Do it, right? That by nature, you don't know what properties you're going to be reporting on until that day, right? So this is a case where the document generator itself needs to be able to, it needs some intelligence. It needs to be able to decide what to fill the template with at the time the document is being generated. Okay, so we call that case driver logic. Driver logic can live in inline code. It can live in its own script, or it can even live in its own notebook. Here, I put it in its own function. So this driver is going to use financial data to look up the members of the trucking industry sector. Then it's going to look up the volume yesterday, and it's going to sort them and take the top n. And then it's going to go about preparing the other slots for filling the template with. Okay. The actual deployment of the document generator itself is still pretty simple. We're just specifying the template and a schedule and also the driver logic. Okay. So I'm going to deploy that and run it. This one hits the financial data packlet pretty hard, so it takes a couple minutes to run. And in the meantime, I think I can show you the results of a previous. I'll wait a bit for that to come. Maybe it'll show up before the end of the. That's a glimpse of the DSP workflow, and it's how it fits into this import, analyze, publish paradigm. You've seen data come in, and you've seen these documents come out. I've shown you how the semantic interpretation helps enable, it sort of streamlines some aspects of the analysis and brings in some stuff that you might not even have thought of doing otherwise. Very importantly, doing data science in the cloud solves the dissemination problem, which in my opinion, in my experience, has been the biggest single obstacle to getting the Wolfram stack into people's organizations for doing data science. Also, I want to leave you with the point that the cloud can be used in a standalone way, but it also hybridizes pretty naturally with the desktop. So these cloud deploys that you see me do are sort of easily managed. If you do data science, if you do data science, and even now without the cloud, you probably have learned to maintain a mental model of the kinds of things that are happening in memory and the kinds of things that are happening on disk. And you say, well, this is a high latency operation and this is a low latency operation. Dealing with the cloud sort of adds another layer to that. You say, well, this is happening in the cloud and this is happening locally, but it's sort of the same idea. And the platform sort of works naturally in both modes. I'd be happy to demonstrate. This is very quick, I understand, and I'd be happy to demonstrate more detailed aspects of this that you would like to see more of. Please, grab me wherever you see me around the conference. Any of these other team members whom you meet here will also be happy to speak to you about it. Thank you.